Alright, y'all, this is going to be a quick video going over yesterday's formative assessment. I'm going to go over the correct answers as well as some of the most common incorrect answers that you guys submitted yesterday. And then you're going to take a quiz right after. It'll be a very short quiz. What I want to say first before we get into it is that I noticed that from looking at the responses, I can tell that you guys, some of you were working together on the formative assessment, which I wish you hadn't, but it really looks like you were, because some of you like submitted within seconds of each other and put all the exact same answers, and they're your friends, so I can tell that I know that you were probably sitting next to each other as well. And the reason I wish you hadn't done that is because, like, for instance, say partner A knows what they're doing and gets all the right answers, and partner B doesn't know what's going on but copies all the correct answers onto their Chromebook and submits them. What I see two people who submit the correct answer. That's what I see. And I don't know if both people did the work or if one person did the work. But the reason that that's bad for you, if you just copied, is because I made the decision to quiz today based on the number of people who got the right answer yesterday. So if you didn't know how to get the right answer, you shouldn't have put the right answer. You see what I'm saying? Because now we're quizzing before you might be ready. But I can just go off what you guys give me. So that's that. Let's get into the first question here. So the first question was, how many bunches is 120 grams of silver nitrate? The right answer was 0.71 bunches. And 62% of us got that correct. The most common wrong answer was 1.4 bunches. I'm going to show you first how I'm guessing you guys got the 1.4, those of you who got 1.4. So silver nitrate is AgNO3, right? Of course, the way I know that is by looking at my periodic table. I can find that silver is Ag and has a +1 charge, and nitrate has a -1 charge. That's how I know that the formula is AgNO3. Just need one of each of those ions. Next, I will figure out the mass of one bunch, right? So Ag is 108, plus N is 14, plus 3 16s. And if I add those up, 108 plus 14 plus 16 plus 16 plus 16, I get 170. And the question is, how many bunches is 120 grams of silver nitrate? So I'm guessing what you guys did to get 1.4 is you did 170 divided by 120. Let me just make sure. Yeah, and I get 1.4 when I do that. So I'm guessing that you knew that you had to do some kind of division, but you didn't think too hard about what these numbers represented, and so you had no idea of knowing which way to divide. But I want to point something out to you real quick. If we label our numbers a little bit more carefully, we won't make that mistake. We just calculated, by adding all those numbers up, 170 grams. That is the mass of one bunch of silver nitrate molecules. 170 grams is the mass of one bunch. And we have, in our problem, 120 grams. And we want to know how many bunches is that. I mean, right away, you can see that this is going to be less than one bunch, right? Because we have less than 170 grams. So right away, we can see 1.4 makes no sense, right? It can't be 1.4 because that's more than one bunch. So the way that we can think about this is we need to think about what is the scale factor to get down from 170 to 120, right? We know that our answer is less than 1, but how many times less than 1 is it, right? So we want to find what's that scale factor there to get down from 170 to 120. And of course, that scale factor, that is your 1.4. So of course, we should say 1 divided by 1.4. That will give us our correct answer. And when we do 1 divided by 1.4, we get our correct answer of 0.71. So that's what we should have gotten. So my advice to you on this is to pay attention when you add up those numbers on the periodic table. What that number is, what that sum is, that tells you the mass of one bunch, right? Remember that. It's the mass of one bunch. And if you write that down, you shouldn't make that mistake of not knowing what to divide by what. Silly mistake there. It's a silly mistake. Let's look at the next one. How many grams is 0.04 bunches of copper 2 chloride? A lot better on this one. 81% of you got it correct. That's up from 62, right? So way better on question number 2. But the most common wrong answer was 4 grams. I know exactly what you guys did wrong on this one. I'll show you what you did. Copper 2 chloride, this is what you guys did. You said copper chloride. Copper has a mass of 64, plus chloride has a mass of 35. 64 and 35 is 99 grams. And then you did, pretty sure, you did 99 times 0.04, which would be the correct math to do, right? And that's how you got 4. That would be the correct math to do. We want to multiply by 0.04, but your problem is that that's not copper 2 chloride. Copper 2 chloride, of course, is CuCl2, so you need 2 chlorines, 64 plus 35 plus 35, and then we get the mass of one bunch to be not 99, but 134. And then if we take our 134 and multiply that by 0.04, that's where we get our correct answer of 5.36. All right, so that's going to be our right answer, our correct answer right there. If you're not seeing why I should multiply by 0.04, let me show you. Of course, CuCl2, hopefully you can understand how I got this far. And of course, this is the mass of one bunch. 134 grams equals one bunch. And my question is asking how many grams is 0.04 bunches, not one bunch, but 0.04 bunches. And I want to know, how do I scale down from one bunch to 0.04? Two ways to do this, right? You could figure out like what to divide by to get from 1 to 0.04, or you can recognize that it's just a multiply. You can just multiply by 0.04, and that works as well. So we should multiply by the same scale factor over here. You see, and we'll go 134 times 0.04, and that's how we get our answer of 5.36. Right, so again, if you write it out like this, and then scale up or down from there, that'll work just fine. All right, these are a bit more complicated, and we saw less success on these. 55% of us got it correct, but I still think this is well within your grasp to do well on this today, especially after I remind you how to do these, because I know it's been a few days, right? I know a weekend happened, and Friday we didn't practice this at all, but hang in there. I think this quiz is gonna go fine. Just pay attention here. So I'm telling you that 20 grams of nitrogen gas is reacting with 8 grams of hydrogen gas, and I want to know how many grams of ammonia are made. What we should do first is kind of don't pay attention to these numbers yet. And what we want to do is we want to just convert these quantities to grams. So remember that this right here represents one bunch of N2. This right here represents 3 bunches of H2. And this number right here, this quantity represents 2 bunches of NH3. Right, that's the first step, is to recognize that and then convert those bunches to grams in the exact same way that we were doing in the last questions. So one bunch of N2, that's going to be just 14 plus 14 gives us 28 grams of N2. 3 bunches of H2. One bunch of H2 would be 1 plus 1, but we have 3 bunches, so it's 3 1 plus 1s, or 3 2s, right? Of course, so that's going to be 6 grams of H2. And we'll do it for NH3 as well. That's 14 plus 1 plus 1 plus 1. But of course, I got 2 of those. So 2 17s is going to be 34 grams of NH3. All right, so this is all just getting ready to answer the question. So what I've done here is I've taken my chemical equation, N2 plus 3H2 makes 2NH3, and I've rewritten it in grams. So another way to say N2 plus 3H2 makes 2NH3 is 28 grams of nitrogen plus 6 grams of H2 makes 34 grams of ammonia, right? And you'll notice that these numbers, right, they add up. 28 plus 6 equals 34. Okay, so that's the setup. That's called getting our recipe. And now we need to look at our question and figure out what our question is asking. Our question is asking, well, what if you don't have 28 grams of N2? What if you don't have 6 grams of H2? What if you have different quantities? What if you have 20 grams of nitrogen and 8 grams of hydrogen? All right, so let's fill in those numbers down here. 20 grams of N2 and 8 grams of H2. What we need to recognize here, or I guess what we need to figure out, is do we have enough reactant to follow our recipe? What do you think? If this is what our recipe calls for, do we have enough reactant to follow the recipe? We don't. We do not, because we only have 20 grams of N2, and our recipe calls for 28. So we don't have enough. So right off the bat, we know that our answer, right, for how much ammonia can we make, we know that our answer is going to be some amount less than 34, right? Because if we don't have enough nitrogen to make 34 grams of ammonia, we just don't have it. So this is going to be a scale down. We need to scale down our recipe somehow. And whatever that scale factor is, that scale factor is going to apply to each of my species here. So what is my scale down then? How do I get from 28 down to 20? Well, you can experiment on your calculator a little bit, and you'll find that this is a scale factor of 1.4. That's dividing by 1.4, of course. 28 divided by 1.4 gives me 20. So then I just need to do the same thing with my 34. And then 34 divided by 1.4 gives me 24.29 grams of NH3. And that is the correct answer. Remember, I am really not a big stickler on rounding stuff. So if you put 24.3, if you put 24.2, if you put straight up 24, as long as I can follow your work, I don't really care. And 55% of us did get that correct. There was not really a most common wrong answer. I tried for a little bit to see what kinds of mistakes you guys were making, and honestly I couldn't really figure it out. So and there were so many different answers that I couldn't sit there and figure it out and show you what your mistakes were. But this is how to do it, and you'll get the right answer if you do this. Let's look at the next one. Now we have 2 grams of iron being consumed, or 2 grams of iron reacting, and we want to know how much copper is being produced here. This is one where you might have found a shortcut. Hopefully you did. This would have saved you a bunch of time. This one was the worst performing question. Only 54% of us got it correct. I'm going to show you a fast way to do this. First, we're going to do the same thing we did before and rephrase our chemical equation in terms of bunches. So I got 1 bunch of copper sulfate and 1 bunch of iron, making 1 bunch of iron 2 sulfate and 1 bunch of copper. I notice I didn't write anything underneath the copper sulfate and the iron sulfate. It's because we don't actually need it, because those quantities just aren't important. They're not mentioned here. The question's not asking anything about them. They're not important to our math here. So all I need to do is just convert that to grams. Right? What's 1 bunch of iron? That's 56 grams. And what's 1 bunch of copper? That's 64 grams. And I can scale down right away, right? Because I know that 2 grams of iron are reacting. 2 grams obviously is less than 56. So my question is how much less? How many times less, I guess? So what is that scale factor there? That's a scale down of a factor of 28. So I'll just use that scale factor over here. So that's 64 divided by 28, and I get 2.29 grams. So that's it. Easy peasy there. Again, remember, I don't really care about rounding. But in this case, if you don't show any work and then you just say 2, I would not be inclined to give you the credit there. In fact, if you don't show any work, even if you get 2.29, I probably won't give you the credit. Please show your work on this quiz. Please. All right. Let's try it. Let's see how this goes. Do your best. This is going to go in the grade book over Thanksgiving break, and then we will have chances to retake it. Okay, so don't worry about it, but it will be in the grade book before you guys get back from Thanksgiving. So please do your best on it. All right, good luck. Actually, please make sure that your privacy folders are set up and use the yellow periodic tables that are on the desks, not your blue ones, please. Oh, and hopefully you have a calculator, because you can't use your phone. Yeah. Okay.